In this lecture, we discuss about energy source. Energy source can be classified into two types. Energy source, it can be classified into two types. One is independent source. Independent source. Second one is dependent source. Again, independent source can be classified into two types. One is independent voltage source. Second one is independent current source. Independent current source. It can be classified into four types. First one is voltage dependent voltage source VDVS. Second one is voltage dependent current source. Third one is current dependent voltage source. Fourth one is current dependent current source. Now first we discuss about independent source. Independent source. An independent source is an active element that provides a specified voltage or current that is completely independent of other circuit element. That is completely independent of other circuit elements. Example, ideal voltage source and ideal current source, practical voltage source, practical current source. First we take one example, that is first one is ideal voltage source. Ideal voltage source. Ideal voltage source means that may be a DC voltage source. This is the ideal DC voltage source. Ideal DC voltage source V, higher potential, positive, negative. Negative is the lower potential. It can be also represented in this way. Positive, negative, V. And this is the AC source. AC source means sinusoidal representation. Here we can write PT. With the DC source, DC voltage source, DC voltage source. This is my AC voltage source. AC voltage source. The best example of the DC voltage source is available, that is called as battery. Battery is the example of DC voltage source. Now we discuss about characteristics of ideal voltage source. Characteristic of ideal voltage source. This is the symbol of ideal voltage source, that is battery. Let this is Vs, your current I, and output terminal. If we connect a load, then we have the voltage V. If we draw the IV characteristic, in x axis we take current and in y axis we take voltage. Then what we get here, Vs is equal to V, directly Vs is equal to V. That means if we change any value of current, voltage value does not change. Since it is a independent source, we can write this is Vs. Now we discuss about practical voltage source. Practical voltage source. Practical voltage source means a resistance is connected series with the ideal voltage source. This is my ideal voltage source. Here we connect a resistance which is connected in series. This is the practical voltage source. Vs, here resistance Rs, here the voltage V. If we connect a load, then current I is flowing. If we draw the VI characteristics of practical voltage source, let we take current along x-axis, voltage along y-axis. For ideal voltage source, this is my Vs. For ideal voltage source, if we have an internal resistance, there is a voltage drop I into Rs. Small amount of voltage is dropped, so that V is not equal to Vs in case of ideal practical voltage source. That means the voltage is decreased. This is the characteristic due to this voltage, that is I into Rs, voltage drop. In case of ideal voltage source, the internal resistance is 0. Here, what is the internal resistance? In ideal voltage source, internal resistance is 0. This is very important point. Internal resistance is 0. But in practical voltage source, there is some amount of internal resistance. Very less amount of internal resistance. Why internal resistance is available in practical voltage source? Due to the presence of electrolyte and electrodes. Due to the presence of electrolyte and electrodes, we have a internal resistance. Therefore, the source voltage is not same as the load voltage. After that, we discuss about ideal current source. Ideal current source. Current source always represented by a arrow mark symbol. That means if we give this symbol, this is the current source, we can write IS, ideal current source. What is the internal resistance? Here the terminal voltage V. If we connect a load, then I current is flowing. If we connect a load, otherwise it is open circuited. Here what happens? What is the internal resistance? Here internal resistance is 0. Sorry, internal resistance not 0, is infinite. In ideal current source, the internal resistance is infinite. If we draw the IV characteristic, we get this type of graph. This is V, this is I. In x-axis voltage, y-axis current. That means here we get in this graph current value does not change. This is Is. After that we discuss about practical current source. In practical current source, what happens? Internal resistance is connected parallel with the sources. Internal resistance is connected parallel with ideal current source. This the ideal current source. Current direction is down to up. Here there is a internal resistance. This internal resistance is connected parallel with the ideal current source. Is, here Rs. Current is flowing in the terminal voltage. That means if we draw the IV characteristic, what happens? This is my voltage, this is my current. For ideal current source, this is my graph. But due to the presence of resistance Rs parallel, there is some current is dropped. This is the graph of the ideal current source. Next we discuss about source transformation technique. Source transformation technique. First one is voltage source to current source. Voltage source to current source. Both are practical, otherwise we cannot convert. Voltage source to current source. This is my voltage source. This is my V. Here internal resistance Ri. Now we convert into current source. Current source means we know that this is the higher potential positive, lower potential negative. Current always starts from the positive terminal of the voltage source. That means here current is starting. This is the direction of current. How we convert? We draw the line. The direction right to left will give right to left the direction. What is the current value? I is equal to, according to the Ohm's law, V by Ri. Same Ri internal resistance is connected parallel with this current source. That means in this way we will convert voltage source to current source. Second one is current source to voltage source. Current source to voltage source. Let this is the current source, practical current source, and this is the internal resistance. Let this is I, here internal resistance Ri. Now we convert into voltage source. This is the direction, that means first one is negative, second one is positive, so that the current direction is same. Current direction is same. What is the voltage value? V is equal to, accordingly Ohm's law, I into Ri. Same internal resistance Ri connected series with the voltage source. In this way we can convert voltage source to current source or current source to voltage source. Next one is dependent source. Next we discuss about the dependent source. A dependent source A dependent source is an active element in which the source quantity is controlled. The source quantity is controlled by another voltage or current. By another voltage or current. It is classified into four types. It is classified into four types. First one is voltage dependent voltage source. Voltage dependent voltage source. Dependent source always represented by a diamond shape. It is also called as control sources. Here we draw a diamond shape. Voltage dependent voltage source, in short form we write VD Vs. In the last letters, Vs means voltage source, hence we give positive, negative. Voltage dependent means we can tell Vx, that means what you understand, voltage dependent voltage source. Second one is voltage dependent current source. Voltage dependent current source. It is denoted by VDCS, voltage dependent current source. Current source always represented by a diamond shape. Last two letter current source means current source always represented by a arrow mark. Voltage source means Vx. Similarly, third one is current dependent voltage source. Current dependent voltage source. CDVS. Same, it is represented by diamond shape. Voltage source, last two letter means voltage source always represented by positive, negative. Current dependent means Ix. That means what we understand? Current dependent voltage source. Last one is current dependent current source. In short form we can write CDCS. Last two letter every time we check current source. Current source means first we draw the diamond shape because dependent source always represented by a diamond shape. Current source means arrow mark. Current dependent means Ix. Current dependent voltage source. Finally, we write two important points. It is also known as control sources. It is also called as controlled source. It is also called as control source. Second one is it is represented by a diamond shape. It is represented by a diamond shape. If you like my video, then you subscribe my channel and press the bell icon so that you will find the new video or upcoming video. Thank you.